Hi, Professor. How are you?
Hi, hi.
I just want to make sure everybody's okay and we're going to start soon.
Yes, I just wait. I think so we should go ahead and get started. Can everybody hear me okay?
Yes.
Yep.
Yes.
All right, very good. Thank you.
Thank you.
How's everybody? Doing all right?
We're
Good.
good.
How about you?
Very good, very good. Yes.
Thank you
All
for
right,
asking.
so I think that this week we will focus on lesson 6, and we're gonna talk about percent, okay? And next week we will have a test, which is a quiz number 2. So we won't meet online, okay? But we will have a test, just like we did for number 1, okay? And then you would find your convenience time to complete on Wednesday, okay? And then I think so should be, all the tests should be ready before 8 in the morning, 8 o'clock. So next week we won't meet, but you will have a test just like we did the for the quiz number 1. Okay.
I have a question. Would I be able to get it a few days early because I'm going to be on vacation?
Yeah, I think you can do it after. Okay, because
Okay.
you can do it. If you cannot make it, just reschedule, and then I think it would be after, not just before. Okay.
Okay, thank you.
Hmm. You can reschedule with me, and then I think I will find available time for you to do it. Okay.
All right, I'll email you then. Thank you.
Yes. Okay. All right. Let's go ahead and talk about percents. Okay. Now here is a definition for the percent. If P is any non-negative real number, then P percent is written like this. All right. So here it is a ratio of P over 100. And what does this mean? That means, we come when we say percent, that means, in other words, that means a P percent, which is equal P over 100. All right. So therefore, the meaning for percent, that means we want to compare the quantity over 100. We'll compare with the number with 100, how many we have, right? So that is let's say we have 5%. And then you want to convert this, okay? And then percent, that means, okay, I need to admit someone to get in here. All right. That means 100 there. 5 right here. All right. So that is 5%, which is 5 out of 100. Right? Everything compare with 100, how much we have this. Okay. So that is, let's see, when we talk about definition here, actually, there's all connect with our children's previous knowledge, which is a fraction, right? Convert with a fraction. So actually, when we talk about this lesson, and percent, decimal, fraction, they all together. Okay. So for instance, like this, you write each of the following as a percent. All right. So 0.03, which is a decimal, right? So we want to convert this as a percent. How should we do this? We can convert this as a percent. Therefore, we have equal 3 out of 100. All right. And 3 out of 100, that means 3%. All right. What about 1. 1 actually is,
100%.
yeah, 100%. Yeah, 1 actually is this. It's 100%. Very good. And then look at this. 100 is go over the right here. I mean percent. Okay. Sometimes you go to the gas station. This is what I found in the gas station. And then I fill in the tank with the gas station. And then will say, oh, 200% guarantee. Have you ever seen the commercial or something like that? 200% guarantee. What does this mean? The gas station, like fill in the tank, and then there's a sign say, okay, 200% guarantee. What does this mean? Anybody?
No, I don't know. That's too much. No, I didn't hear that. I'm not good with percents.
Have you ever seen that sign before? I did, a Hux.
I never seen
gas
the
station.
sign, but I think it would mean double the chance, twice as likely.
You got it, yeah. And then people look at commercial, they use this, they use a percentage. When I look at this, okay, I look at, it's a double guarantee, right? Yeah. And then 2%, that means a double, right? And how about 1? 1 actually is 100 over 100, which is 100%. Does that make sense to you guys?
Yeah.
Well, if it makes sense to you, can you do number 3?
120%.
Yeah, 120. Yeah, okay, you can do this problem in your head. Very good. Right? You can do this problem in your head, right? So we can convert this 1.2 as what? 1. Actually, this is a 2. Actually, is a 20. Is that right? Can we convert like this? Yes or no? It was a fraction.
Yes, I think. Yeah.
Because everything we need the button here, we make it as 100. That would make sense, okay? Of course, you can use 1 or 2, 10, right? But actually, on the bottom, we need to convert as 100 because of percent. Is that right? So therefore, 120 out of 100. Yes, you got it. It's a 120%. Does that make sense to you guys for this problem?
Yes.
Yeah,
All right.
after you explained it to me, yeah.
Yeah. I think that when I explain to you, I'm trying to use the more conceptual knowledge. Did you see this? Instead of give you the rule, I mean, this is important when you develop a lesson plan for your children. You need to give a meaning and then give a kind of a meaningful lesson. Okay, what does this mean? Okay,
Mm-hmm.
yeah, that would make sense that would helping children to learn mathematics. If we just pass in the rules, it's not fun, right? But we explain the detail, what's going on, that would more make sense for people, right?
Mm-hmm.
Okay, number 4, which is a 0.00042. Can you take a minute, convert this as a percent? All right. Take a minute to convert this as a percent, okay?
Now this is where I start to have heart attacks, so I don't do good. The only thing I would do is I would go with using the calculator over 100, but I mean that's not what we want to learn, right? Not the easy way out.
Don't you have to put it over 1,000? No, 1,000. You don't put it over 100. You put it over. Hold on, let me count the spots. Because it's not. It's over. You have to count the spots. The tens, the hundreds, the thousands, the 10,000s. So 42 over 10,000. Is it 10 or? I'm guessing.
Good guess.
I think I'm counting the spots because you have the tens, the hundreds, the thousands, the 10,000s is the 4 spots. So is it 42 over 10,000?
10, no, actually, you know, it will count now, 100,000. But anyway, here. Okay. Let me give you a way how to do it with the tricks, okay? Are you guys ready?
Yes, sir.
Yes.
So, for instance, I'm gonna get back to this problem, okay?
Mm-hmm.
The 0.03, right? I'm gonna go back to this problem, okay? Go back to this one. I'm gonna change the color that helps you to see visually. 0.03, and how when we change this into this, right? And then we count the decimal point to the left or to the right for how many? To the left or to the right?
To the right, 2 spaces.
Oh, to the right. Yes. So that's the 1. That's the 2, right? So that's why we have 3, and we have the 3%. Is that right?
Yes.
All right. So we count 1 and 2, right? So we convert this as a 3%. This is the kind of tricks. You can count the decimal point. And how about this one? And we count 1, just like this, 1 and 2, right? 1 and 2, right? Oh, decimal point right here, right? So therefore, it's a 0.042%. Are you with me? Yes or no?
All we have to do is count over 2 times. That's it for every time.
Yeah, 1 and 2. Yeah, 1 and 2. That's easy.
Right? Well, that's very easy. Yeah. Okay.
And then what about if we have a 1? Decimal point is right here, right?
Yeah. So it's a whole number.
1 and 2, and then we 1 to 0. So that'd be 100%. Is that right?
Oh, cool. Okay.
If we have 1.2, that's easy, right? Count 1 and 2, 120. Does that make sense to you?
Yep. Lots of weight off of my head. Yep.
Yeah, that helps you for problem that
for me. Yeah. No more headaches so far. Thank you.
Well, always go to the basic. Okay. If I insist using this problem explain to you, that's not correct instruction. I will go back to this problem, the one you have for previous knowledge. Does that make sense? And build up your knowledge, then we go back to this problem. Is that we build up your knowledge and then go back to this problem? Does that make sense to you for the way how we teach children?
Yeah, to figure out the concept. Sometimes, very easy.
Sometimes the teachers too stubborn. They say, "I want you to do this. I want to do this." And then what happened?
Yeah,
it will fail.
That would confuse the kid and fail them. Yes.
You fail them. Why not just go back to the previous knowledge and you helping them and say, "Okay, I'm counting," and you can say, you know, because you want to use in the children's language, say, "Oh, let's do rapid jump, and just jump in 1 and jump in 2 to the left or to the right, and get something interesting and fun, right?" And then they will jump. They will jump for you in the classroom, I believe.
Yeah. Exactly. Yeah.
Yeah.
Very
the kids
good.
they will jump. Okay. So finish up this. So what about this problem? Okay, I'm gonna clean up my board because I don't have room. Next problem, number 5. Can you take a minute to do it? Can you take a minute to do it while I was cleaning this? There's some more space to do that. Okay.
Cool. 60%. I should be, I hope.
You are absolutely correct.
Oh, thank God. Okay.
Yeah. But actually, I have 2 different methods I want to show you, okay?
Oh, okay.
Maybe you do the method 1, maybe you do the method 2, okay?
Okay.
So 3/5. All right.
That's what I did.
That's the method 1, okay? Method 1. I want to just convert everything on the bottom is 100. Can we do that for this problem?
Yeah.
So if I like to make this is 100, so therefore I have 2 times 20, is that right? To make it
Yes.
as a 100.
Right.
So at the same time, times
Times
20
20.
on the bottom, on the
Cool.
top. So I get 60 out of 100. So therefore 60%. Does that make
60%.
sense to you?
Yes.
And luckily, this problem like this 5, we can convert as 100. So we can do that, right? We can do that.
It's easy. Yeah.
Yeah, we can do that. What about the second method we can do? The second method we can do that means all the fraction problem we can do this problem, okay? So for instance, we can do the long division. We take a 3 divided by 5, and then therefore we got a 6, 30, and then 3 fifths actually is a 0.6, and then actually whatever you want to do, you can do the counting the decimal point.
Yeah. Count 2 times over.
And 2, yes. We can count 1 and 2, right? 1 and 2. So decimal point right here is 60%. Is that right? Same as this problem. Is that right?
Yes.
Yes.
Only 1 and 2, right? Yes. So either you want to do this way or do the first problem or the first answer or second, method 2 should be okay. But this problem, number 6, can we do the first method 1? Yes or no?
It won't end up even, no.
Yeah, it won't let you make it as 100. So only way we can do is number 2. Is that right?
Yes.
The only way we can do. But the number 2 is, all the fraction problems should be okay. Can do that, all right? But sometimes you have to observe if with the denominator we can make it as 100, then we'll do the method 1, okay? All right, so this problem, yes, we cannot just, make it as like a method 1. So therefore, we just take 2 divided by 3, and then actually 0.0 and 6 times 3, 18. And then 2 right here, and 6 again, 18 again, 2. Oh, kind of
Keep going on.
Keep going on, which is 0.666 repeating. Is that right?
Yes.
So therefore, we convert this one is we're moving the decimal point. So therefore, it's 66.6% and repeating.
Okay.
Okay, so I have a question because it's like 66666. The 0.6, it would stay 0.6, not 0.7. Even though it's okay.
Yeah. It will repeat it because this is called last
Hanging.
last week we talked about terminating decimal or non-terminating decimal, right? So this keep going is non-terminating decimal because we have a repeating. So actually it's a 66.6 repeating percent. This is more precise, okay? Does that make sense to you?
Yes.
Yeah.
All right. Let's move on to next one. Write each of the following percent as a decimal. Oh, now we're gonna have a percent and we're gonna convert this as a decimal, right? So again, 5%, which is a 5 out of 100. Are you with me? And which is a 0.05. So we convert this to 5% is a 0.05. Does that make sense to you?
Yeah.
How about 100%? 100% we know 100 over 100. So that's a 1. How about 250%? All right, which is equal 250 over 100, right? And then look, 100, and then you want to do 100 there, right? So therefore, This is a 2.5.
Mhm.
Now, how about this one? 6.3. 6.3 actually is 6.3%. Are you with me? And we count a decimal point, okay? Because we divided by 100, right? So remember that we talk about division, right? Divided by 100. Divide is this way, right? To the left or to the right? To the
To the
left,
left,
right?
2 spaces.
Two spaces. Yes, that's a 1. Divided by 10 right here. Divided by 100 right here. Oh, that's a 0.063. So answer is 0.063. Does that make sense to you for this problem?
Yes.
All right. Now, how about number 5? Can you take a minute, try it? 1/3%.
I just know it's 33, like, percent, but repeating, but I don't know how to get there.
Yeah, 33 repeating. Yes, it's a three repeating.
Yeah.
All right. So here, 1/3. So I'm gonna take a 1 divided by 3, and then this is a 3, got a 9, subtract this, and 0, 3, 9, 0. Oh, you got a 0.333 repeating, right? So therefore, this is 0.333 repeating percent. Are you with me for this?
Yes. Yeah.
Repeating, okay. But I will not write repeating right here, okay, because I need to taking care of a percent. So therefore, I leave some space for this. So are you ready to move the decimal point? Yes or no?
Yes. Oh my God. I don't know.
Oh, that's 0. That's all 2. So how many space we need to move? That's the 1 there, and that's the 2 there. So therefore, 33.333 repeating. That is 33.333 repeating, right? So therefore, this will be
33.3% repeating.
yeah. So therefore, well, just a second. No, my things are
No.
no.
Mm.
Yeah, we counting wrong.
Okay.
Just a second. Okay, so we are here, right? The 3%, 1/3 is right here, right? 1/3 is right here. So we convert it as like this, right? So since we gonna divide it by 100, that means a percent. So actually, it's not this way. We're counting. It's not this. It's not to the right. It has to be to the left. Why? Because let me show you.
Over 100.
Yeah, so we divided by 100, right? So divided by 100 actually is to the left or to the right. To the left or to the right.
Maybe to the right, no? It's not?
Yeah.
Left, wouldn't it?
Yeah. So we have to the because we divided by 100. So to the left. That's for how many?
Maybe to the left? Oh.
2. Yeah. Because divided by 110 right here, divided by 100 there, right? So therefore, the answer will leading you 0.003 repeating. Are you with me for this? Or you want me to do one more time?
Is it because it's a fraction, it's already a percent, so you move it to the, I mean, it's a fraction of the, that's why you move it to the left instead of the right?
That's right, because we want to convert it to decimal. So that means that this is a percent, that means divided by 100, right? That's right. So that's the, because we want to convert this to decimal. So moving the decimal point divided by 100, that means divided by 10 right here, divided by 100 there. So therefore, the answer is 0.0033. That means 0.33 repeating, 0.03 repeating. That will be the answer. Does that make sense to you?
Yes.
Mm.
Sometimes, the problem, you need to make your mind clear. Should we go to the left or to the right? Because to the right, the number will get bigger, right?
Right.
And if you move it to the left, that means a divide, right? And since here is a divide, so that's why divided by 100. Does that make sense?
Mm-hmm.
And here is divided by 10 here, divided by 100 there. Is that clear?
I think so. I think I'm understanding. Yeah.
Yep. Okay, very good.
Okay.
Next, there's some problem for percentage. 100% of 900. 15% of 900.
15%. Oh my God. How's that gonna be?
So here is some method we can talk about for to finding out the percent calculation. Okay, so here is I think so. Oh, yeah, the small space. Yes, here is one problem. 15% of 900. I would say this is a method one. Okay.
Mm-hmm.
Now method one is this 15%. So I will say 15% of, that means the times
Times.
900, okay?
Mm-hmm.
So 15%, that means 15 out of 100. Are you with me?
Yes.
Times 900. Are you with me for this?
Oh, wow.
All right.
15.
900, actually 900 over 1, is that right?
Yeah.
And which one we can cancel? Can we cancel 0, 0 over here? Yes or no? Because the 900 actually is 9 times 100. So that's why up and down we have the same 100. We can cancel out. Are you with me for this step?
Yes.
Cancel out for 100. Okay. So we leave as 15 times 9, and then which is 135. Does that make sense to you?
Yes.
Wait a minute. Sometimes we have the answer, and we want to make sure. See, this is a quantity of 900 for total, and then 15% of right here, and then it's a 135. Yes. So we double check our answer is correct. And then here as a whole is 100%. Is that right? 900. Does that make sense to you? We always using the segment to check. Do we get the same, correct answer, right? Does it make sense to you to double check?
Yes.
All right. So that's the method one. Method one we can see of is the times, okay? And that's the method one we can do, okay? Problem number 2. How many percent of 80? How many percent of 80 is equal to 20, okay? How many percent of 80 is equal to 20? Okay. But I'm not showing you the another way, okay? This is from Japanese textbook and also Singapore math. They use the segment method. They create two segment, okay? Now whatever percent put in this this line, this is segment. Whatever number we put in this segment, okay? So percent, this is 0%, this is 100%, okay, 100%. Now, since problem is here, say how many percent of 80 is equal 20? So how many percent of 80 right here? 80, that means 80 is 100%. Are you with me for this? How many percent of 80? 80 is 100%. Does that make sense to you?
Yes.
And 20, we have quantity. 20 is right here. 20 is right here. Are you with me for this?
Yes.
Right. There's a number fill in this segment. So what we're looking for? We're looking for the box right here. We don't know, right? We're looking for this. Does that make sense to you for the picture, for visually? Yes or no?
Yes.
So now I can set up the equation for this. A box over 20, which is equal 100 over 80. Because they have the same quantity, so therefore they are equal, right? So in this is so we can set up equation like this. This over this is equal this over this, okay? To solve for box, can we cross multiply? Yes or no? Can we cross multiply? Yes or no?
Yes.
Yes.
This is called a proportional reasoning. Proportional reasoning, that means two fractions, they have the same ratio. It's the same ratio, then we can cross multiply. For instance, one half equal 2/4. 2/4. 1 half equal 2/4. 2/4.
True. Yes, true.
Now when we cross multiply, look at this. 4 times 1, 4. 2 times 2 is equal 4. Is that right?
Yes.
Oh, same ratio. How about another one? 1 half equal 3/6. 2/4. Equivalent fraction. And now look, cross multiply. 6 equals 6. Is that right?
Yes.
So therefore, if this is a foundation, is okay for student, then we can go back here, right? So now we have 80. We say 80 a box. Well, in middle school, we say X. But in the elementary school, we just using a box. So that will be 20 times 100, 80 bucks, which is equal to 2,000. And then both divided by 80. Both divided by 80, a box, that means 2,000 divided by 80. And we would get just divided by 80 for both. More space for this. But actually, we can, we can cancel the 0 there, make the calculation easier. All right. 16, 4, 25. So the answer is 25. So answer is 25. We'll put on here 25%. Does that make sense? If 100 is this much quantity, which is go for 80, and then 25% is 20. Does that make sense? Yes or no?
Yes.
All right. So about 25%. Yeah. Okay. So that's the method 2. Method 2. What about next problem? 80% of how many equal 160? Okay. So this method, you probably cannot see any textbook, okay? Method 3. Who made this? Who created this? I create this, okay? I make this. Let me show you the way I create, okay? You may not able to see any textbook for this, but it always work. 80% of how many equal 160? All right. So for this problem, either you can use the method 1 or you method 2. So here I'm going to introduce the method 3, which is I create, okay? 80% is a part. So I was thinking of part or whole. 80%, what do you think? Is a part or whole?
A part.
Part.
So I will put on the part there. Now, next, of how many, if this is a whole or part?
Whole?
It's a
No,
Whole.
no, it's a part. Hmm?
With a part.
Look at this. Oh, whole 80 is 100%. Is that right?
Yes.
So can I say whole for this? Yes or no?
No, it's a part.
It's a whole, right?
It's a whole.
Oh, it's a whole.
How many percent of something? And that something is a whole, right?
Mm-hmm.
Like
Okay.
how many percent of 80? And that 80 is a whole, right? And how about 20? 20 is a part. Is that right? So 160 is a part or whole?
A part.
Part.
A part or whole? 160 a part or whole?
A part.
Yeah, very good. It's a part, right? So part over a whole equal part. Yes, correct, right?
Yes.
So this is what I would do. Part whole whole. Part whole whole. What does this mean? That means par over par, which is equal 1, which is whole over whole. So I will fill in the information part. Part is actually right here. I'm gonna fill in part is 80%. Part actually 160, yes or no? And whole is a 100%. And then whole actually is the number we don't know. So we have 80 over 160 is equal 100 over $1. This is another way, and then we still close the multiply for this. 80 $1, which is 160 times 100 divided by 80 for both, and 16,000 divided by 80, and so therefore it will be 200. So now fill in this 200. Makes sense or no? You have 80% of the whole is 200, and which is equal part 160. Does that make sense to you for this method?
Yes.
Pa pa ho ho. You can just label it and you fill in a number. Pa pa ho ho. Or if you like a Japanese or Singapore method, you can use the second method. All right, segment method, or you want to using the what the multiplication and off transfer to times is still okay. Right? It's up to you. So you have a 3 different way of doing this problem. Okay. So now I'm gonna give you a minute to do this problem. Okay. Then you take a minute to 17 over 800. You can do any method you want, okay? You can do method 1 or method 2 or method 3. It's up to you. Take a minute, do 17% of 800. Okay, are we done or we need a minute? Let's check your answer on the board. If you want to take a method 1 and you want to times 800, are you with me? You want to do method 1 and 7100 times 800. 800, that means 800 over 1. Is that right? So therefore, yes, because it is a 100, you can cancel 0 there. So we have a 17 times 8. 17 times 8, 136. Did you get a 136, yes or no?
Yes.
All right. Let's do next problem, okay? Take a minute to do this problem. Second problem. How many percent of 60 is equal 15? How many percent of 60 is equal 15, okay? All right, are we done?
Yes.
Can we do papa ho ho?
Yes.
Ho, pa.
Mhm.
Pa over pa is equal ho over ho.
Mhm.
And a ho always 100%, is that right? 100% on here. But here, percent, we don't know, put on there. And pa, we know, we know, pa actually is, we can, okay, pa is percent. All right, just a second. Is right here. We don't know how many percentage, but it's 15 for this. And then whole always 100, and we have a 60, right? And then can we cross multiply, yes or no? Did you get a 60, a box, get a 15 times a 100? So we have 60 bucks, which is equal 1500 divided by 60 for both.
25. Yeah.
Yeah, 25. So you got 25. So
Okay.
put in here 25% of the 60 is 15. Does it make sense? Yes. So
Yes.
makes sense, right?
I
Okay.
have a question. I have a question. Under
yeah.
you have 60 bucks and you have a 60 bucks and you have the line. What's that number up under there? What's the
60 bucks, right? 60
okay,
times
right up
bucks.
under, then you have the line, and what's the number up under the 60 bucks?
60.
It's
60.
60. Okay, got you.
60
I was making
divided
sure.
by 60. Yeah,
60 divided by 60, because then you cross multiply, got you.
Yeah.
Or
Plus
multiply by.
Yeah,
Got you.
divided by 60 for both. So therefore, the box would be 25, right? So we take a 1500 divided by 60, and then we got 25. All right. How about let me see, next problem. How about we take a 5-minute break, okay? And we come back.
Okay.
Can you leave the last problem on the screen so I can copy it down?
Oh, okay.
Thank you.
This one?
Yes.
Okay. And that's take a 5-minute break, okay? All right. Let's back to class and then continue our discussion for percent. And then we're gonna talk about some of the word problem, okay? A house that sells for $92,000 requires a 20% down payment. What is the amount of the down payment? So I think so when we purchase a house, we require a down payment. So we can set out the equation for this. We have a 20% of 92,000. So we're looking for how many for this, okay? So earlier we talked about we have method 1, method 2, and method 3, right? And I think that this problem, I think that I would just simply use the method 1. 20% times 92,000. So therefore we have 20 over 100 times 92,000. So I think there's so many zero there. So I think so the first step I would do, I'll just cancel the 0, 0, 0, and 0, 0 there. Are you with me for this process?
Yes.
Yes.
Then we have 20 times 920. So take 20 times 920. So the answer would be 18,000 and then 400. And that means that you need to have this much money in order to purchase a house of a $92,000 house. Does that make sense to you?
Mm-hmm.
That means you need to have this much cash in order to buy a house, a $92,000 house. All right. Let's do problem number 2. Can you take a minute to set up the equation for this? John has 45 correct answers on an 80 question test. What percent of his answers are correct? Can you take a minute to set up the equation, percentage equation? Okay. So what percent? So we're looking for what percent? We don't know what percent. Of 80 questions, which is whole, and which is equal 45. Did you get it right for this? Yes or no?
Yes.
So we're looking for the percentage, right? So now I'm gonna use the Japanese or Singapore math, use a second method like this. And a review for the second method, whatever the percentage put in here, whatever the number you put in here, right? So 100% right here, which is equal 80. Are you with me? And 45, that's the 40, 45 around 45. Oh no, that's too much. 45 is right here. 45 is right. That's a 40 and the 45 right here. Okay. Now 45, we don't know. Are you with me for this picture, yes or no?
Yes.
Yes.
Then if this is okay, then we still have because elementary school, we use a box. So we use a box over 45, which is equal 100 over 80. Can we cross multiply, yes or no?
Yes.
Yes, just cross multiply. So we have 80 box, which is equal 45 times 100. So we have 80 a box, which is 4,500 divided by 80 for both. A box. The 80 divided by 80 discount. So 80, 4,500 divided by 80. So we get 56.25. So all conclusion for this one, John had 45 correct, which is 56.25. Did he do good on the test? Yes or no?
Yes.
No, it's a 56%.
80. Oh, that's very good. Very good.
No, it's not good. Yeah, actually he failed.
No worries.
Yeah.
That's in here.
Yeah. See, that's why we use a percentage to determine student performance. Does that make sense?
Yeah.
Yeah. That's why we are using percentage to determine student performance. All right. Is that okay with you for this problem? Yes or no? Can we move on?
I have a question. When we do the test or the homework assignments, do we have to do it in a specific format, like a specific way, or does it matter any of the ways that you show us, as long as?
No, no. As long as any way should be okay.
Okay, just checking.
But I would just encourage you to learn as many methods as you can.
Yeah.
Okay.
Yeah,
Because some methods are just algebra. Some method like this one just pretty much just algebra, right? And some method is good for student more visual representation, right?
Yeah. Okay, I understand.
This one, I understand all the other methods, but this one, and maybe it's different when you get into different problems, but I always skip to the last, like when I see the problem, I always think of the 45 divided by 80. Like I always think of the last step first. So then when you have all these boxes and all of this, I know we have to show all of our work, but I always, like when I first saw the problem and it's like what percent of 80 equals 45, then I always think of 45 divided by 80 and it comes up to the 56 point. You know what I'm saying? But I know we have to learn how to teach it and teach all the steps and why you get to that. But all the boxes and stuff make it kind of confusing.
I'm exactly like my sister. Yep, I'm exactly like you. Yeah.
Yeah. I like when we did the other one and you was like part, whole part.
Yeah.
And it was like the.
No, I like that. That one I could understand, but this one, yeah, no. But I, like you said, I reached the end before I reached the first step.
I do too, because when we did the when we did the other one, it was like what percent of 60 is 15. I just automatically thought 15 divided by 60. But then this is the better way to explain it, but it's hard to think backwards.
Yeah. Well, the reason I like to introduce so many different methods because sometimes like the school, if a school district update the textbook, maybe they show the way of the second method, like everyday mathematics. They do this, right? So you will know the more method you learn, and then that you look at the textbook, what's this school district adopt, and you have confidence to teach. Right? So I mean, that's the more method you learn, the better. Okay.
Yes.
All right. So next problem. Next problem. Can you take a minute to do it? So you can use any method you want to do. Method 1, method 2, method 3. It's up to you. 42% of the parents of school children in the Carbondale School District are employed at the Southern Illinois University. If the number of parents employed by the university is 168, how many parents are in the school district? Can you take a minute to set up the equation for this one? So we're looking for this problem, we're looking for the part or whole. We're looking for
a part.
Part, for the part, yep.
We're looking for the part or whole.
Part.
Oh,
Oh, we're wrong. I think it's not the
Could be
part. Oh my God, I feel so bad.
Yeah, it's okay. It's okay. But just have you to think. Sometimes you look at problem, you have to think about. I'm looking. What's the question asking? Is looking for part or for whole, right?
Oh.
So now you'd be looking for a whole, right?
Yes.
42% of the whole school district. We don't know, but we know the university employee is 168. Does that make sense?
Okay, that opposite. I thought the whole was 168.
Yeah, 168. The number of parents employed by the university is 100. Look, this is a school district, and this is South SIU,
Okay.
right? And SIU here is 168. And what is the total of this, right? So can we do, okay, since this is with part and whole issue, can we have part or part? Can we do that? Can we do part,
Yeah.
part, whole?
Yes, yes, we should.
Part, whole.
Part, whole. Okay, part.
So part is a 42%, which is 168. And whole always 100%, and we're looking for a no, right? Can we cross multiply, yes or no?
Yes.
Cross multiply. Yeah. See, actually, when you have the set out the equation, next step is much easier, right? Once you have set it up the equation, the next step, just cross multiply. So therefore, we have 42 bucks, which is equal 168 times 100. 42 bucks, which is equal 16,800. Can we divide it by 42 for both to find out a bucks?
Yes.
And then once we take 168 divided by 42, and we're supposed to get a 400 for this. So now if this is a 400, I'm gonna fill in this. The whole school district is a 400. Does it make sense, yes or no?
Yes.
Yeah.
Then the whole thing here is 400, and then SIU here is 168. Does that make sense to you for this problem?
Yes.
Next. Take a minute to think about this problem. Kelly bought a bicycle, and a year later sold for 20% less than what she paid for it. If she sold the bike for 144, what did she pay for it? Can you take a minute to set up the equation? right? Let me ask you, what does it mean 20% less?
It means she sold it for 80% of what she got it for.
Yeah. You don't always take a 20% to do it. Actually, no. Actually, it's 80%. You want to sell a used car? Are you going to sell more or less? You want to sell a used car or used bike? Less, right?
Less.
Of course, you have to say less. If you say more, who's gonna buy your car? Nobody, right? No one was ready to buy your bike. Is a more expensive than the used one, right? So therefore, you have to sell less, right? So since it is less, so we have to think about this. 80% of what is equal 144. So what did she pay for it? That means the original number, the original price she pay for it. Does that make sense to you?
Yes.
So we can do, either way. You wanna do papa ho ho, you wanna do segment method, it's up to you, okay? Yeah. But how about if I do, if I change it, like I wanna do, I wanna say, oh, up is the times, right? Can we do that? Yeah, we still can do this problem with the times. Times a box, which is equal 144. We can do the method one, it's up to you if you want to do. So 80, 100 times a box, which is equal 144.
Maybe.
So we have 80 bucks over 100, which is equal 144 over 1. And we cross multiply. And then cross multiply, we have 80 bucks, which is equal 144 times 100.
180.
And then that 80 bucks, which is equal 14400, 14,400. And we divide it by 80 for both. And then the original price, we get 180. Well, now we got a 180, we'll put it in here. Does it make sense for a 180? The original price is 180, and then we sell for less for 144. Yes, makes sense. Okay. How about the last problem for today? Okay, take a minute to do this. Set up the mathematical equation. You can do method 1, method 2, method 3. It's up to you, okay? You can pick up any your comfortable method to do it. If you pay $42 for a garment on sale for 30% off the original price, what was the original price? Looking for what's the original price? All right, what's your equation? 30% off. What does this mean? 30% off original price. What does this mean?
70%.
Yeah, 70%. Don't forget it. 70%. So 70% of the original price, which is equal 42. Did you get right for this equation setup? Yes or no?
Yes.
Yep.
Mhm. About, I want to do my favorite way, which is a papa ho ho. And this, right? I will just label it, all right? So that'd be 70 over 42, which is equal whole, would be 100%. And then here is unknown. And we can cross multiply this. 70 a bucks, which is equal to 42 times 100. 70 a bucks, which is equal 4200. Now we divide it by 70. So bucks would be, the unknown number would be 4200 divided by 70, which is equal 60. Did you get 60, yes or no?
Yes.
Yes.
So the answer, double check our 60. If a 70 is a 60, 70% of a 60 is a 42. Yes, yes. Then you are right. Very good. All right. Do you have, okay, we are here for today. Do you have any question for today?
No.
Okay, if no questions, I think I will be staying here for answer you any question. All right. If you have any question, you can stay here to ask me. If not, we are here for today. Okay.
Okay.
And then next time we won't meet online. Okay. Next time we will have a test.
Okay.
All right. Next time we won't meet. We will have a test. Okay. See you next time. Bye bye.
Thank you.
Thank you, Professor. Take care.
Bye bye.
Take care. Bye bye.